the documentation well structured, because a lot of people have issues either with the configuration or with the understanding, uh, or with the SSL related issues, right? So because of this, they wanted me to create a end-to-end documentation and also a masterclass. All right, so we are going to discuss from the scratch for the people who know the basics and fundamentals well and good, but additional to that, we are going to discuss few more things that we may not be aware of, right? I'll show you a few examples. We know about public and private keys, but is public and private key required everywhere? Yes, we'll see that, right? So what is SSL and why SSL is required? We will understand uh, the advantages of SSL and necessity of SSL and what exactly it does. It is not only about the secure thing and encryption. There are multiple things, right? We'll discuss about SSL certificates. We'll discuss about the types of SSL certificates and authorities, and what is the chain of trust. We'll understand with a real world analogy, and yeah, what is encryption, why we need encryption, and what is decryption, who does the decryption, what is required to do the encryption and decryption process. We'll discuss about the key pair, what is public and private key, and yeah, symmetric and asymmetric encryption. These are the two types of encryption methods, symmetric and asymmetric. Yes, each one has a different way of workflow and functionality, and both are used in SSL. Both are used in encrypted communication, right? We will see which one is used when, at what point, which one will start the SSL handshake, and which one will continue with the rest of the uh, encrypted communication, right? And okay, so this is a summary and what exactly is a SSL handshake, step by step. And these type of diagrams, there are a hell lot of diagrams in this, but each diagram with a different perspective and with a different term. For example, uh, you know I'll say that okay, server will send the certificates to the client. So here in this diagram I will show you, and in the next diagram there will be like SSL. Okay, let us say this is TLS 1.2 version. So using TLS 1.2 version, how the handshake works, this is a diagram, right? And there will be another term. I will explain the another term in this diagram. All right, so this is about Diffie-Hellman methodology of sharing the key. So here the diagram, the concept will be same, the SSL handshake process will be same, but here the terms will change, the algorithms will change, the method of generating the key will change. So we will discuss, we will come across the same thing again and again. What same thing? Okay, client says hello, server says hello. So again and again you will get, sometimes you may get bored, but the concept here is understanding different ways. If you are using RSA, if you are using ECDH, right, we'll understand ciphers. Okay, when we come to cipher, we'll understand what is a cipher, what is a cipher seat, and what exactly this cipher seat means. We'll decode that, and we will understand again the same thing with this sequence diagram. Again, it is a handshake. Again, the client says hello, server says hello, and server sends a certificate. Here, there are two things involved. One is RSA, and the other one is ephemeral key, which is ECDH algorithm, right? So we'll understand the flow, but each and every diagram will be different. The concept will be same. I hope you got the point, what I'm trying to say, right? Guys? Yes, no, all right, confused?
Yes.
Yeah, great. Okay. So the previous one was SSL handshake using TLS 1.2, and now the latest is TLS 1.3, and this is much faster. Why it is faster? What is new in 1.3 TLS version? Okay, we'll talk about the round trips, right? Uh, TLS 1.3, again the same client hello, server hello, but this time this is a small diagram because the the number of steps involved in communication between a client and a server is very less. Why and how, we will discuss this. All right. So it is because of RTT, which is round trip time. Yes, round trip time. And what are all the things removed? We will discuss in 1.3. And in 1.2, why there are two round trips? Again, this is a master class. It doesn't mean that we'll go very fast. Uh, in order to work with SSL and TLS, your fundamentals and basics should be very strong. We need to know each and every term uh, with the SSL and the parameters that we are going to. We are not at. We are not discussing about the tools and utilities, how to create the keys, how to create the certificate, CSR, and all. We are just understanding today what happens after the CS certificates or self-signed certificates are installed on the server, and how the client communicates with the server, what happens in the background, how the data is encrypted, how the data integrity is maintained, how the authentication is maintained, how the security is maintained, about the decryption and encryption process, how the validation happens, right? So all these things, there are lots of things to understand. So once you understand all these things, it will be very easy for you to work on the configuration part, work on the configuration part and troubleshooting and issues, right? So why TLS is slower? Again, with the help of a diagram. And there are new things like revocation checking. Okay, what is revocation? We'll see that one as well. CRL and OCSP. This is a real-time live validation happens. So we'll understand the differences. There are again two things in OSCP. Uh, the OSCP Online Certificate Status Protocol, and the other one is OSCP Stapling. Uh, this is a real-time check. The burden is not on the client, but it is on the server. So we'll see all these things today. So this is the agenda, and once we are done with this, we'll start with IKeyman. You know what is IKeyman? IKeyman is a GUI tool or utility that ships with IBM HTTP server, and sometimes WebSphere application server as well. Depends upon the type of edition you are using, the software package. And if you don't have access to the GUI, you can use ikey CMD, right? So the same thing I have. Let me show you. IKman and IKCMD. So this is a GUI tool, and if you don't have access, you can use IKCMD with the help of a few parameters. It is just like GSK CMD, right? We'll see how to create a CSR. We'll see how to create a self-signed certificate. We'll discuss about these parameters, everything once, and the same will be the concept will be same, and we'll do it on WebSphere application server, creating a self-signed certificate, and you know how the things work on admin console. And also there is one more part, that is configuring on plugin. So plugin doesn't easily trust the backend application server without a proper validation, and that validation is done with the help of a certificate, right? So this plugin also has a KDB file like IHS, which is proprietary vendor specific, meaning IBM. So IBM uses KDB format for as a key store for IHS and plugins. And when it comes to WebLogic, Oracle uses Wallet for Oracle HTTP server, right? So this is proprietary for IBM. And here comes OpenSSL. So we'll discuss what is RSA, and yeah, we'll see when we going to discuss what is hash. What is, you might have seen RSA with SHA-1, SHA-256, SHA-384, and what exactly this means. What is hashing? Why the message needs to be hashed before it is sent to the server, or we'll understand these terms, the functionality, how it works uh, in the encrypted communication, right? So these are different algorithms, hash algorithms. And then OpenSSL. Yes, there are few limitations with OpenSSL. There are few limitations on IKman. There are few limitations on GSK CMD, and there is one more utility called GSA C API CMD. So we call it usually GSK CAPI CMD, but actually it is Global Security Kit developed in C language, and it is an API, and it is a command line tool. So GSK C language, API application programming interface, and CMD command line. So that is GSK CAPI CMD. And GSK CMD is the older version, and GSK CAPI CMD is a newer version, and with advanced features, with additional flags. And yes, we will see the differences between both of them. Generate the same output, but with additional flags on GSK's CAPI CMD. And we'll see the differences. We'll see the limitations of GSK, and we will see the limitations of OpenSSL, right? So OpenSSL is very advanced. Like most of the things you can do it on OpenSSL. For example, if you want to extract a key, a private key, you need to use OpenSSL. You cannot do it with the IKman. You cannot do it with the key tool, right? Key tool utility. We'll come to that key tool utility. The key tool is a Java-based utility that ships with IBM SDK and Oracle JDK. So you can use the key tool utility. And we might have seen mostly X509. So we'll see what exactly is this X509. And with the help of OpenSSL, we'll see how to generate a CSR, how to convert the keys, the certificates from PEM to PKCS8. Where do we use PKCS8? And what is PKCS12? What is JKS? What is DER binary format? and CER, CRT, ARM, right? These are all the different formats of certificates and keystores. So conversion between different formats, all these things we'll see practically. All right. Yeah. How to inspect the certificates, how to check the validity of the certificate, and yes, this is about openssl, and then GSK CMD and GSK CAPI CMD. As I said, it is based on C language and it is an API uh, and used as a command line. So we'll see both. We'll understand what we can do with both things with the examples. All right, and formats, which one supports which format, and the differences, uh, functional comparison between both. Yes, recommendation when to use which one based on your